Yes, I want to exit. Welcome back, me. What am I doing back? I don't know. I don't know what I'm doing. Okay. Okay, everything's working. Very good. Trying to decide on... Well, I won't announce my surrender yet. And I have all the tabs that I'm not supposed to have simultaneously opened. Uh-oh, y'all can see where I popped my zit. That's embarrassing. Oh well. Whatever. But yeah, no. I decided, while I was thinking of what to do, I decided on something to do. I decided we could type out the definition of a standard deviation here in the streaming notes. I don't know why I didn't think of that before. I just feel so scatterbrained without my tablet pen. And then I turned on the tablet and I don't know. It all went downhill from there. At least as far as the drama in my brain goes. Oof, that is embarrassing. Well. There we go. Excuse me. Alright, so. Well, first things first, we want to define the mean, right? So we are going to say or not the mean, but the how did we do it in this one? Just called it the mean average? Okay. Sure. Okay, so I was making that more complicated for myself. Anyway, excuse me. Define the mean while I'm about to. Thank you very much, who farted. Thank you. The mean is a value that is defined as, we're going to call this value mu. Yes, the sum of a given set of values. Whoops. Divided by the number of values in your sample. So we would say sum I equals 1 raised to the n and say that is x sub I, where each x sub I is a value in a sample of, or a set of n samples divided by, yes, n, the number of samples. So actually really fast. Consider a set of values sampled from a Gaussian population, whatever. Hopefully that makes sense. X sub 1, X sub 2, dot dot dot, X sub n. Yay! That is our sample values. Alright. And here. Mean average. Our sample. Nope. Nope. That's not what I meant to do. But get out of here. There we go. And actually, you know what might look a little bit neater? Where am I missing a closed brace? Oh, of course. There we go. Doesn't that look much better? Outliers with regards to like your sample? I mean, not with sample, your probability distribution or whatever. Also really fast, you have the... Well, actually, I don't want to go there. Then we have the variance of our sample. Sigma squared is equal to Langle X, oops. Oops. We don't need that. Squared plus, or no, it's minus p squared. Thank you, Vampire Frog. I appreciate it. I like how you called it a recipe book. That is one way to think of these. But I have taken math classes. Very good, very good. Is a line graph. Yes, 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 yes. But right now we're just looking at just good old-fashioned mean and variance. I like your analogy, and you know what? This is like my kitchen. My LARP station is my kitchen. How about that? But if I could actually cook something with this stuff, I don't know. That's actually kind of next level. Well, be careful driving home, Johnny on the spot. And welcome, welcome. Gaussian. Do you know what Gaussian means, Vampire Frog? It means it's a probability distribution or a population wait, hold on. How do I want to say this? Pretty much, if the population of whatever you're drawing your sample values from, if those sample values are coming from a population that's normally distributed, it's said to be Gaussian. Well, yeah, the bell curve, yeah, Gaussian, yeah. I was just being a smartass. What do y'all think of that? Yeah, the bell curve. What is the actual probability distribution for a Gaussian? We could type it out. But really fast, we should define angle x squared angle is equal to if I'm not mistaken. Nope, I was right. Very good. Very good, Renzo, very good. Is the fringes of either side on the curve? Exactly, very good. So something that would have a high or low standard deviation. Oh, and really fast, we forgot to define standard deviation. So sigma is equal to square root of angle x I didn't mean to do that. There we go. And you can have plus or minus. Very good. Gaussian distribution, i.e. the bell curve. Hoo-hoo. What do y'all think of that? What was it again? Let's see if I can't find it in one of my books. Aha, I do believe I found it. Oh, this is important also. It's the limit of the binomial distribution for a large number of trials. That's something to keep in mind. Pareto theory, aka the 820 rule. You'll have to elaborate. So P of x, which is just the probability of sampling a particular value x equal to whoops. E raised to the whoops. U squared. Oops. We'll put that minus up here since that's whatever. It doesn't really matter. Same thing. % of the output from a given situation or system is determined by 20% of the input. I've never heard of that. Where's that from? There it is. And so this, I guess, is the normalization constant right here. I.e. the thing that makes everything sum to 1. And also right here. Actually, I will put it in the quote thing since I'm just gonna write straight from what it has in here, or copy straight what they have in here. Let me have the binomial distribution for a large number of trials. Any of y'all know what the binomial distribution is? Can you tell me what is 13 but also 50? No, I can't. What is it? By no means. Well, good to see you're still here, Billy. Thank you. For instance. Oh, Lord have mercy. The number of successes in n Bernoulli trials with the probability of success p is binomially distributed. Very important. Very good. Do y'all know what a Bernoulli trial is? A Bernoulli trial is something that can well, how do I want to say this? I'm just going to read out what it says right here. I apologize, everybody. A variable, or a Bernoulli random variable, is a variable from an experiment that has two possible outcomes: success with probability p or failure with probability 1 minus p. What do y'all think of that? I don't know about that. Where did you hear about this? Who farted? FBI crime statistics. Y'all. Binomial distribution. Decide. Binomial coefficient. So, and this is the number of ways you can arrange. No, the number of ways you can choose k objects out of n objects. Or n choose k. Nope. How is it? How do they do it? No, that's not how they did it. Nope. Then joggle copy paste in of the Pareto theory. Okay, one second. Oh, hold on, y'all. Hold on. There we go. Where n factorial just means n times n minus 1 times n minus 2 times dot 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 times 2 times 3 times 1. Oh, we're using x instead of k. Okay, fine. Alright, here's the binomial distribution. And it is a discrete probability distribution, so we're going to use capital P. Whoops. I would have forgotten this, or obviously I forgot this because I am... whatever. And the mean for this guy is... where n is the number of samples, I guess, taken. No, oh, never mind. N is the number of successes in n Bernoulli trials. Oh wait, no. N is the number of Bernoulli trials. Should have written sigma squared, shouldn't I? way more of 1350 principle, which is actually more like, what? You tripping. Well, thank you. Who farted? Thank you for appreciating. Oh yeah, we were gonna write out stuff for the Bernoulli distribution. Oh yeah, and really fast. Binomial distribution. The number of successes in n Bernoulli trials. I don't know. What does that have to do with anything?